everybody, very good afternoon to one and all. This is Vijay Mahavar, here host for today's webinar session. The topic for today's webinar session is Oracle Analytical Functions. A brief introduction about me. I am Vijay Mahavar and an Oracle technologist. I am a member of AIOUG, that is All India Oracle User Group, Listagg, that is Oracle Development Tools User Group, Oracle Technology Network, the OTN. I have been associated with Oracle technology since last 10 years. The session is targeted for the audience who are working in SQL developer, as a SQL developer, who are working in PLSQL development, DBAs, database architects, software engineers, senior associates. The agenda for today's session will be introduction to analytical functions. What are analytical functions? The difference between analytical functions and group functions. Some of the analytical functions like lead and lag will be discussed. Then first value and last value. First and last. Window clause. Listagg and nth value, which are the two new analytical functions released in Oracle 11G Release 2. Winding up with performance tips at the end of this session. Now, what are analytical functions? Analytical functions are built on top of aggregate functions. They return group-wise data. They return group data row-wise. Aggregate functions return group data, a group result for the whole group once, whereas this analytical functions return row-wise group data. That is one of the advantages of analytical functions, you can say. They are used in doing complex operations like for reporting and statistical purposes. They should never be used as a replacement for aggregate functions. Some of the analytical functions which I have listed down here are divided into basically two broad categories. One, those are dependent on the order of records, and one, those are not dependent on the order of records. Like lead, lag, rank, dense rank, row number, first value, first, last. They're all dependent on the order of records. The order of records plays a very significant role in them. Whereas the functions like sum, count, average, minimum, max, irrespective of the order of records, returns the same result. The two, as discussed, the two newly released analytical functions like Listagg and nth value are released in the Oracle 11G Release 2 version. Now, aggregate function, as most of you must be familiar, are sum, count, average, min, and max. The ones which are not dependent on the order of records, as shown in the screen. The syntax for analytical function is very simple. This has function name and the argument. The argument can be like one, or it can be like more than one, followed by over clause, then partition by, order by, window clause, which are optional. Window clause is an optional one, and it will be discussed later on this session. The example of analytical function is shown below. I'll just demonstrate this with the help of a query. I've already kept the queries ready for the session. I have connected to my local instance of my database. Some problem. As you can see here, the result is displaying department number, EMP number, E-name, count, E number. So the count is calculated for department wise employees count 1, 2 and 3 for department 10. For department 20 it's 1, 2, 3, 4, 5, 5 employees are there. Department 36 employees, so on. Let's take a more logical example. There are like 14 employees in the department in the employees table. So in the aggregate function we get only one record showing 14, whereas analytical functions can display department wise aggregate information like three employees in department 10, 5 employees in department 20, 6 employees in department 30, which was not possible and which would have taken more lines of code without analytical functions. As you can see here, the snapshot of the query when we are using analytical function, and we are not using analytical function. It's a normal SQL using aggregate function. Now moving on to some of the basic analytical functions. The first set which I'll be discussing here is lead and lag. Many times we might be required to display the records in the next row in the present row. So we use lead in that scenario. The syntax of lead is quite different from what we have seen so far. It contains 3 arguments. First is SQL underscore expr, that is a SQL expression. Then offset from where it should be treated the current row, and the default in case there is no matching next record, what will be displayed, and followed by the over and the analytical clause. Let's discuss this with the help of an example. In this example, we have department 10, 20 and 30. In department 10, we have clerk having salary of 2450. I want to display the salary of the next employee King along with the record, the clerk. So 5000 will be displayed, King's salary will be displayed along with the clerk's salary. So this has to be done for all the employees in all the departments. So for example, in the King's record, we have the salary of 5000, and the next salary of Miller, which is displayed along with the King's salary, is 1300. But in case of Miller, we don't have any other employee in the department 10 followed by Miller. So we have 0 as displayed, as we have mentioned the defaults clause. The offset here is 1. It shows the immediate next record, which is King in the clerk salary. The syntax of lag is quite similar to what we have seen in the lead example, with just the offset goes in the previous row. I'll show you the example of lag. Instead of salary of clerk coming, here the salary of clerk will be coming along with the salary of K. As you can see here, the salary of clerk is shown with the salary of King. So previous row's record is shown in the current row, but the clerk doesn't have any previous row, and it shows 0 because the default value here is 0. The next set of analytical functions which I'll be discussing out here is first value and last value. First value, as the name suggests, it shows the first value in the series and displays in the current record. The syntax of first value is quite simple. It shows first value with one argument that can be SQL expression over followed by the analytical clause. I'll demonstrate this with the help of an example. The example here displays the first value of salary. So the salary of the department 10 here is displayed as of the employee clerk. We have 2450. It is displayed with all the employees in department 10. The department 20, the first value of salary of Adams is 1100 and it displayed for all the employees in department 10 1100. Department 30 similarly we have 1600 and displayed with 1600 everyone. If you see here, it's being done department wise because we have mentioned the partition by clause as department number. Had we ignored this clause, it would have displayed the salary of clerk for all the records, all the 14 records. The next set of analytical function which I'll be discussing is first and last. First function is also called as keep first. Here this is quite different from what analytical functions which we have discussed in the previous slides. Suppose there is a scenario wherein we have multiple records in the first level. In that scenario, we might be interested in knowing the aggregate function and apply the aggregate function on the first rank. For this, we use the dense rank. So we should be familiar with the rank and the dense rank feature before proceeding with this analytical function. So I will demonstrate the simple scenario using rank and dense rank. We might be interested in knowing a rank of all the employees on the basis of their salary, or it can be depending on the marks in case of a class, of the marks of the students in the classroom. So for simplicity, I'll be showing you the example wherein we have the rank displayed for the employees on the basis of their salary. Here we have department number 10, 20, 30. The department number 10, we have the rank on the basis of the salary. For Miller, the salary is 1300, so it displays rank 1. Clark, it's 2450, rank 2, and King, rank 3, in the ascending order of the salary. This continues for each department, all the employees within the department. If you notice here, in the department 30, Martin and Ward, they're having the same salary. So the rank for them is 2 and 2. So the next rank in the series, rank number 3, is not assigned to anyone. That is what the rank does. In case of a tie for any rank, the next rank in the series is skipped. As you can see in this scenario, the rank number 3 has been skipped, and the next rank in the series, rank number 4, has been assigned to Turner, having salary of 1500. There might be scenarios wherein you might be interested in not skipping the series but continuing with the rank as they are. Like you might be interested in showing Turner with salary 1500 as rank 3 rather than 4. So we use dense rank in those circumstances. I'll be demonstrating that with the help of a query already designed for this. As you can see here, the Turner with salary 1500 is now having the rank 3. This is what dense rank does. It doesn't skip any rank in case of a tie. Now the first and the last analytical functions, they heavily use this dense rank feature. The dense rank is used as one of their, majorly used in their syntax. The another key feature which you need to keep in mind by using first and last analytical function is that they don't have any order by clause, and they don't support Windows clause, which we'll be seeing in the latest section of this seminar. I'll just demonstrate one example of first. This example displays the displays the functioning of how first value works, first analytical function work. Here you see that we have department number 10, employee number 7782, e-name clerk, salary 2450. If you see the dense rank, we have the first rank 1300 that is displayed for all the employees in this department 10. For department 20, the rank we have is 800 that is displayed for all the employees within department 20. And department number 30, we have the lowest salary is 950 that is displayed for all the employees in department number 30. So this is what dense rank does. Moving on to the next section, that is Windows clause. Some of the analytical functions which takes window clause are listed here: average, count, first value, last value, max, min, sum. By the word window clause, we mean that in the partition we again have a subpartition wherein we can define the window within which we need to select the records. The window clause is very dynamic in nature. The syntax for window clause is a row or range between start expression and end expression. The start expression can be any of the following: unbounded preceding, current row, preceding or following. Similarly, end expression can be any of the following: unbounded following or current row or preceding or following. I'll just demonstrate this with the help of an example. In the present example, I have employee number, department number, and hire date. The hire date I have just taken the year figure out of that. I have extracted the year figure and I have shown it, and I have calculated the count of all the employees with hire date, with partition on the basis of hire date, and having 3 rows preceding to the current row and 1 row following. So the count of all the employees who were hired, 3 employees hired before the present employee, and the 1 employee after who got hired after the present employee. So it basically returns the count of all the employees. 3 employees before the current employee was hired, and the 1 employee who was hired after the current employee. So currently, if we go by hire date, it's 1980 was the first person who was hired in the employees table, as per the employees table. So if you see the current row, it is only 1. We don't have any other employee in the hire date 1980. So it considers the current row as also included in the count factor, and it displays 1. In the case of 1981 year, we have 1 and 2 which are displayed here. There are 5 here, and in case of 1981 for employee number 7521, we have 3. That is because the current row, 1 previous row, the 1981, and 1 over here. In 7566, we have 2 records from 1981 from the previous 3 rows, the present record, and the 1 following. For if you take the scenario of 7698 employee number, we have 3 rows preceding, that is these 3 rows, the current row, and the 1 following. So all 5 rows are met here. So that's why we have figure of 5. Similarly for 77882, 7844, 7654 employee, and rest. In case of 1982, we have the current row as only 1, and there are no employees who were hired in the year 1982. 1987 we have 2 which are displayed here. So that was the first count showing the window clause with 3 preceding and 1 following. Similarly, we can have here instead of 3 preceding, we can have unbounded preceding and instead of one following we can have current row. So all the count of the employees who were hired before, all the employees before who got hired before this current employees hired it, and the current employee. So the count of these two will be considered in the count star. Again, there is one more example which shows between 3 preceding and 1 preceding. So all the employees who have got 3 employees before this and 1 employee in this window will be getting the count star. That is a very simple example demonstrating the window clause. These are some of the points you need to remember while using the window clause. The window clause we have row and range. The row actually considers the number of rows before and after the current row, whereas the range considers the value which defines the range of the value. It can also be in a negative, since the row cannot be in a negative number, but the range can be in a negative depending on the values we are using for that. Now to wind up the analytical functions, I'll be discussing the two newly released analytical functions in the Oracle 11g release 2 version. The first in the list is Listagg. Listagg is actually lets us achieve by concatenating all the values in a particular group by using any delimiter, which was earlier done by in the previous releases by using decode and group by aggregate functions. This is now being handled by a single Listagg analytical function. I'll be demonstrating the uses of Listagg analytical function with the help of an example. I have already kept the queries ready for the interest of the time. I'll be demonstrating here. We have employee table wherein we have 14 records. Now we have department 10, we have some employees, department 20 we have 5 employees, and department 30 we have 6 employees. Now we might be interested in knowing the employee names, command separated list of employee names department 10. Similarly for department 20 I might be interested in knowing the command separated list of all the employees. So the Listagg function helps in achieving that. Just there is a typo. Apologies for the typo mistake. As you can see here for department 10 we have 3 employees, Clark, King and Miller. They are concatenated and shown in one single row. Similarly for department 20 we have 5 employees, their comma separated list is shown here, and department 30 the comma separated employee list is shown here. Here I have used the delimiter as comma. In case I would have used as pipe, I would have got pipe here rather than comma. It's a very simple analytical function which achieves a lot by just minimum lines of code. We have within group here order by ename. If I would have given here as descending order, I would have got Miller, King and Clark in the reverse order. The next newly released analytical function in the series is nth value. The screen is showing the result I am getting by executing this query. This is the result I get when I execute this query, which I have shown you. The next is the nth value. It is also newly released analytical function in Oracle 11g release 2. We have already seen the analytical function first value and last value. It displays the extremes value in the series. Nth value achieves, it's a more generic form of first value and last value, wherein you can select any one of the values within the range or within the series, not only the extreme values of first value and last value. Like I might be interested in showing the 105th record in the series. I might be interested in showing the 7th record in the series. So nth value can also be used to display the records first value and last value by putting the values like an nth value column name comma 1 or nth value column comma 1 from last. So this also helps in achieving the first value and the last value. It's a more generic form of first value and last value. I will demonstrate this with the help of an example. Here I am finding the difference for top two employees in a department. The top two employees in the department with the salary. Just for the better readability, I'll also include the salary column in this. As you can see here, I have department 10 showing salary of King, that is 5,000, Clark 2450, Miller 1300. The first two salaries in this department is of 5,000 and 2450. So difference of these two is which comes to 2550, and that is being achieved by nth value. Here I have created a formula column with alias top two underscore difference. As you can see, the first value is used here for getting the salary of the 5,000 of the King's or King salary, and the nth value is used to extract the second value in the series, that is 2450. Since King doesn't have any employee previous to him or in the series, he is the first one, there is no value displayed here, there is a null, and the difference of these two is 2550, which is displayed along with the Miller salary also. In case of Scott, department 20, I have Scott with 3,000 salary and Ford with 3,000 salary. Since the salary of these two are same, I have 0 displayed for all the employees in department 20. Similarly, for department 30, I have 2850 and Allen 1600. The difference of this is 1250, which is displayed for all the employees. Since Wake is not in the first in the series, he doesn't have anything against him. This is a screenshot which displays the snapshot of the result of this executing this query. Performance tips. Analytical functions are in itself very performance boost for our SQL queries, but some points we need to keep in mind is that we must use the indexed columns for defining the partition by and the order by clause. That is a generic rule of thumb for all the performance issues which we face in the SQL queries. The thing is that we have to have indexed columns in partition by and order by clause. We must keep our tables index always analyzed. Since analytical queries are heavily used in reporting environment, we need to make sure that we have jobs scheduled to keep our tables and indexes, and all the stats are gathered regularly. The optimizer mode should be choose. Sorting for computing partition and order by clause takes time. The order by and the partition by clause, which we have seen in the analytical clause, is the most time consuming clause in the whole analytical queries. So we need to take care of using only the indexed columns in that, which we have already seen that. Where we have queries with multiple analytical functions, we need to make sure that we don't have non-indexed columns and two different non-indexed columns in the same query. This might cause a performance issue, and instead of having a optimized result, we might be facing in a very poorly designed queries, which might take more time. Any questions? Any questions we have? Okay. Besides this list of analytical functions which I have demonstrated here, we have many other analytical functions beyond which are not covered in this scope of this session. We have like analytical functions based on generating sales forecast of the company. We may be having uh, many scenarios like getting the sales volume which is happening in the future, or it can be like a weather forecast. So depending on this trend which we have, like sales of in different seasons of the year, we can calculate what are the forecast for the given product in our organization. For that we have reg underscore slope, and it's like very heavily used in marketing department, and it really helps a lot. We have like covariance, variance, standard deviations. These are the other analytical functions which have not been covered and heavily used. Okay. uh, as I have discussed that we have max and min. Max and min is already a aggregate function, and when they are used in analytical function, the core logic, the meaning of this analytical function remains same. Only that is it shows the minimum value within the defined partition. I think we are running short of time. These are some of the useful links which I have shared here, and which I have used in my reference as a reference for preparing my presentation and webinar. The first link is the Oracle documentation link for Oracle 11G release 2. Second is for newly released analytical functions from the Oracle base website. Third is psoug.org, which list all the other analytical functions which I have discussed, like reggr underscore slope, and covariance, variance, standard deviations. For any further queries or any offline discussion, you can very well approach me on my blog on https://listdba.wordpress.com. I'm also available on Twitter, vmahavar. Thanks a lot. Have a nice day.